Hi, my name is Chang Wan Ryu. Along with David Wang and Minh Nguyen, we're trying to generate images of the consequences of wildfire. Specifically, when we have a street view image of a house, we wanted to transform that into an image of a house on fire. One of the main challenges was in the dataset. We found it extremely difficult to get paired images of houses before and during fire. Instead, we collected an unpaired set of images from Google Image Search, Flickr, as well as GIFs and video frames. And we tried three different approaches that can work with unpaired images. The first such approach was CycleGAN. CycleGAN uses conditional GAN and takes an input image along with the noise factor Z. Cycle consistency added loss function and training two pairs of generator discriminator networks. This allows us to use unpaired image dataset. The second approach was CUT. CUT is multi-layer patchwise contrastive learning to map patches in an image to map to a similar point in a learned feature space while using other parts of the image as negatives. The final approach we used was MUNIT. To apply burning effects to a building, we recombine the content code of the input building image with a random style code in the target burning style space. Different style codes lead to different outputs, hence multimodal.
My name is Minh Nguyen, and I'll be presenting the first part of our results. For CycleGAN, increasing the resolution of the input and output images from 256 by 256 to 512 by 512 improved the realism and quality of the fire, smoke, and houses in the generated images. CycleGAN was able to maintain the appearance of the buildings while generating somewhat realistic fire and smoke in appropriate parts of the image. However, sometimes the generated images would only tint regions of the image orange or black. Based on CycleGAN's loss graph, the model may have been focusing too much on cycle consistency, which is shown by its performance with maintaining the building's realism while not generating the best fire or smoke. Our final CAT model performed about as well as our CycleGAN with 256 by 256 images. The fire and smoke were in reasonable locations, but their appearance were not realistic. Removing anti-alias, downsampling, and upscaling reduced blurriness compared to our initial model, but significantly increased training time. The final model training was stopped at 74 hours, which is less than halfway through the default 400 epochs. We believe that long training time is a downside of CET, and the model will perform better with more training.
Increasing input image resolution noticeably reduced blurriness and overall distortion. MUNIT was better able to capture style characteristics of flames and smoke compared to other models, but often distorts the appearance of image content by applying unrealistic color shifts or adding noisy artifacts. This may be a result of applying styles to incorrectly mapped content codes. We hypothesized that MUNIT requires additional input data of both classes to adequately map the content space, as distortion occurs most often when uncommon objects appear in input images. For example, oddly colored first stories of buildings, uncommon building facades, or large bodies of water. Additionally, MUNIT does not penalize distortion as heavily as CycleGAN and CUT by default, which highly weigh cycle consistency loss and patchwise contrastive loss respectively. Using a test set of 11 paired images, the members of our group completed a survey of generated image quality based on three categories: fire, smoke, and building realism. Based on a 5-point rating system, CycleGAN using 512 by 512 images was the best at preserving building realism, while MUNIT was the best at generating realistic-looking fire and smoke. The CycleGAN model could be improved by changing the weights within the loss function, specifically reducing the cycle consistency loss weight. MUNIT could be improved by adding a mask to restrict MUNIT's changes to buildings and trees in the image, since MUNIT sometimes distorts objects in the background. The main bottleneck for CUT was training time, so training longer could improve the model. Additional future work includes creating a larger and more strictly curated dataset, as well as trying other GAN architectures.